We'll determine the wavelength of light using the double-slit interference formula. Here's the problem. In a Young's double-slit experiment, the slit separation is 0.040 millimeters and the screen is 1.5 meters away. The first order bright fringe, where m equals 1, appears 2.1 centimeters from the central maximum. Determine the wavelength of the light. First, we use the bright fringe condition. For small angles, sine theta is approximately x over L. The condition is d sine theta equals m lambda. Substituting sine theta with x over L gives d times x over L equals m lambda. Now solve for the wavelength lambda. Lambda equals d times x divided by m times L. Substitute the values. D is 4.0 times 10 to the minus 5 meters. X is 0.021 meters. M is 1 and L is 1.5 meters. This gives lambda equals 4.0 times 10 to the minus 5 times 0.021 divided by 1 times 1.5, which is 8.4 times 10 to the minus 7 divided by 1.5, resulting in 5.6 times 10 to the minus 7 meters. Remember, for double-slit interference with small angles, the wavelength can be found using lambda equals dx over ml.